Okay, so thanks everyone who's joining now. I can see participants are beginning to join us. In the couple of minutes before we kick off, I've heard a rumour that not everybody is here early in the morning, like I am in London, and Ben is in Bristol, I think. So if you're joining from somewhere outside the UK, can you just let us know where you're from in the chat? And it's quite nice to get a global picture of who's here, who's already had their day at work, and who's waiting for it to begin. Okay, so we're up to 25 people. I think I'm going to start with a quick intro before I hand over to our speakers today. So for everyone who's here and anyone who is in the process of joining us now, welcome to today's Expert Talk Online. Today, it's a conversation about security at HMRC. My name's Julia Bellis, and I'm a product manager at Equal Experts. And I'm currently working with some very smart people building pricing algorithms for holiday rental properties. And I'm very pleased to introduce our speakers today. We have Ben Conrad, who is head of product for the multi-channel digital tax platform for HMRC. For those of you who have joined us from outside the UK, HMRC is the UK's tax office. Ben's worked with the MDTP for 5 years. It's a platform as a service, which now hosts over 1,000 microservices. And the focus of the platform is to meet the needs of the many, many agile teams who build and maintain customer-facing services for HMRC. And our second speaker is Gerald Benishke, who has a software engineering career spanning 25 years in the public, financial and telecom sectors. He's a consultant with Equal Experts, and he's currently leading the AppSec program at HMRC Digital. He was previously an architect and tech lead delivering flagship HMRC programs. And before joining HMRC, Gerald worked with Money Supermarket, Barclays and MBNA as a software architect, tech lead and senior developer, so a man of many talents. And Gerald's primary interests are middle tier services, databases, security, automation, and functional programming. So before I hand over to them, I just want to let you know that we're going to take some audience questions towards the end of the conversation. So if you think of any questions, please add them using the Zoom Q&A function. So without further ado, I'm going to hand over to Ben and Jerry. Thank you both.
Thank you very much, Julia. I think probably that intro has covered off my half of the talk, so I might just skip that bit now. Hello, everyone, and welcome to how HMRC Digital Services secures services at scale. Honestly, with my list, this is just going to get harder and harder. We're going to split this talk up into 2 sections. So I'll just reiterate kind of who I am. I'm Ben Conrad. I'm head of products at MDTP. The tax platform, the multi-channel digital tax platform, we will call it all sorts of different things. It's all the same, though. You may have seen me in this room previously getting interrupted by children or indeed adults. I make no promises that the same won't happen again today, I'm afraid. And I'll just let Gerald say hello.
Hi, and I'm an AppSec snooper.
So we're here to talk about how HMRC secures the digital services that we host on MDTP. And as I say, we're going to split this into 2 parts. So I'm going to mostly give the context, and Gerald is mostly going to give the interesting bits of information. Some of you may already be familiar with this, but I'll give a really quick overview. HM Revenue and Customs are the people responsible for the anxiety-inducing brown envelopes you likely occasionally receive if you live in the UK. And we're also responsible for ensuring that people and organisations in this country pay the right amount of tax and duties. In an effort to reduce the postage costs, they have for many years been building digital services, which we do in line with the approach defined by the UK Government Digital Service, GDS. To make this whole thing easier, HMRC have built this multi-channel digital tax platform, MDTP, although I'll probably just refer to it as the tax platform thread. The platform exists to make building and hosting those digital services as easy as possible. It is a platform as a service, and this quote is actually from Equal Expert's digital playbook on how to build a digital service, a platform as a service, a digital platform, if that's what you want to do. MDTP itself has been in existence for the last 8, nearly 9 years, and we host all of HMRC's customer-facing digital services. Now, that might be services with a front end, it might be ones which only have an API. We currently have about 250 different digital services. It really depends how you count them, because there are different ways. Since we have this microservices architecture, there are well over 1,000 microservices being built and maintained. As a platform, we provide a set of infrastructure and tools to allow these teams to build, test, and deploy services written in Scala with the Play framework, and we think we're pretty good at it. We talk about MDTP being an opinionated platform. The opinions we hold define the paved road, the golden path, the bowling alley of success that we provide to our users, with the intention that following that paved road will allow the teams to build services quickly and efficiently. The headlines of those opinions relate to technology. So you need to use Scala for writing services, you use Mongo for persistence. But they're also about practices. We have opinions about using continuous integration, deploying frequent small changes through automated pipelines, and having really good test coverage. The payoff for this is that if you follow our opinions, stay within the guardrails, keep to the paved road, don't go careering through the undergrowth and getting stuck in the weeds. I'm stretching these metaphors as far as I can. Then you can focus on solving business problems and delivering value really, really quickly. And the other result of this is that the services on MDTP are built using common technologies and, where possible, common components and common patterns. And as we'll talk about later, there's a huge advantage to having that degree of consistency in the applications that we host. So AppSec, this is kind of what we're actually here to talk about. For someone, let's say, with a mild speech impediment, there's a risk it will sound much more rude than it actually is. Application security, which we differentiate from our platform security team. So in some ways, this is a full split, but as a platform, we've always taken responsibility for the security of the platform itself, the infrastructure, the features that we build. However, it's obvious, I think, that just concentrating on the infrastructure, just on the platform, is only one side of the coin. The platform itself can be hardened, and you can say that it is relatively secure, but that doesn't really count for a lot if the applications we're hosting are riddled with vulnerabilities that are easy to exploit. We may be able to build really very strong walls that will withstand all sorts of attacks, but if the windows and doors are wide open, it's not going to provide a high level of protection. The services hosted on MDTP have always, and I hope always will, have responsibility for their own security. We're not trying to take that responsibility away from somebody. But because of the consistency that we're able to have, we can effectively look for vulnerabilities not just in a single service, but in hundreds of services at a time. And we can also provide tooling that enables teams to proactively check for known vulnerabilities in their own code as part of an automated CI/CD pipeline. So I guess we'll talk briefly about why we're bothered about doing this. There are lots of reasons, actually, but whether it's our platform security team or the application security team, the goal is essentially the same. We want to prevent security incidents. A security incident for HMRC can be categorized in a large number of different ways. And indeed, there's a lot of guidance on what constitutes a security incident. Some of it is reputational. We are a government department and we don't want to end up being the subject of a article on the BBC or indeed anywhere else, or at least not for negative security reasons. But also we are a large target. We process payments of hundreds of billions of pounds a year, and we legitimately pay out billions, even in years without a global viral pandemic. The applications on the platform process the data for around 45 million individual UK taxpayers and around 5 million companies. And that data itself is really valuable. And the UK government has legal responsibilities to protect it. So the AppSec team are focused on looking at the security of those applications that we host. I think this is the definition of AppSec from that universal source of truth, Wikipedia. There are three aspects of AppSec defined here: finding vulnerabilities, fixing those vulnerabilities, and if you can find and fix them before anyone else is able to exploit them, then you'll likely prevent them. Indeed, there are other steps you can take to prevent even widely known vulnerabilities from being exploitable if you have the right protections in place. As an example of this, there have been recent attacks where an application might have been susceptible to the initial vulnerability. However, something like a proxy blocking egress back to the internet to everything other than a list of allowed URLs would likely be effective in blocking active exploitation. And that, I guess, is an example of defense in depth. So why do we need it? The question is not so much about whether we need security. It's really about, again, the difference between application security. And I think I've covered this to an extent, but I guess I want to point out that we've always done a lot to ensure the security of the platform as a whole. We use all sorts of different tools to make sure that the infrastructure that we use to build the platform has been hardened and is secure. But it's only really recently that we've taken steps to really investigate the security of the applications that we are hosting. And one of the reasons for that, I guess, which we'll come on to a little bit, is because it was being looked at before, but on a very case-by-case individual basis. And the reason that we're driven to do this is because it's clear that we can often improve the security, not just of a single application, but of a whole set of applications. And this is all down to the scale we operate at. Yes, 1,000 microservices. I mean, again, it depends slightly how you count them. There are well over that number in development. There's slightly fewer, I think, in production at the moment. And these numbers are always a bit rough. In reality, there are more in lower environments. There are stubs, etc. And they fluctuate a bit. So I actually had to update this number, even though I kind of ran through this talk probably only a month or so ago. There've now been 170 new microservices built on MDTP in the last year. Not all of those will be running in production. And sometimes we get to decommission old services if you get them replaced or they're no longer needed. How you count the teams, so we say that we've got about 100 teams. Again, that's quite difficult because often there will be a one-to-one relationship between a team and a service. You know, a team looking after a single big service, but then often you might have a big service that actually has multiple different features and it will be looked after by multiple teams. We also have a concept of live service teams, and they may be looking after 50, 60, maybe 80 services that are held to be feature complete. They are in live. They have gone through all of the live assessments that they have to do. And there are lots and lots that fall between those two extremes. And of course, the teams vary in size as well, depending on the complexity of what they're looking after, I suppose. The point is that we're operating at significant scale. And we have our own in-house catalogue of the services, and we'll explain a bit more detail about that later and how useful it is as a tool. But it is a really important tool for operating all of these different microservices. So some people might recognize this kind of screenshot. as I mentioned, one of our opinions is that the services on MDTP are built by agile teams. We ask and expect all teams to use continuous integration. There should be no waterfall development taking place on MDTP. I mean, everything I say has got exceptions, but we frown at it and suck our teeth a lot. To enable this, we provide CI/CD tooling, which at its most easy to screenshot means Jenkins. Although if I give a version of this talk next year, that will likely have changed. At the moment, each commit on GitHub can trigger a pipeline of actions to build your software and generate an artifact, generate a slug, and that artifact is then stored in Artifactory, where we can do all sorts of scanning on it. That artifact is then deployed into our pre-production environments. It's tested, it's deployed to the next environment and run the tests that are configured in that next environment and so on. This is all fairly standard stuff. The testing will vary depending on the purpose of the microservice. So a front end will likely include things like browser compatibility testing, which is obviously no use tool for a back end. As a platform, we provide tools to allow automated security testing as part of those pipelines. So currently that's SAP. This is really just a vanity stat, isn't it? There's quite a lot of changes to code. You can see clearly Christmas on this graph chart. And I think Easter there in April, slightly less dramatic. That sharp drop in commits just at the end of May, the start of June, is the weekend of the Queen's Diamond Jubilee. God bless you. It was a lovely weekend, terrible for productivity on the platform, apparently. Each of these, 36 million lines of code could be built into a new artifact and then will be tested through the pipelines I mentioned just now. If tests fail, then the pipeline will fail and the artifact won't progress any further. And it's possibly worth mentioning here, we don't do automatic deployments to production. So deploying to production itself is always an additional manual step, and I suspect always will be. So again, lots and lots of deployments. It's interesting, I guess, that there isn't a big spike in any particular month. I think that's indicative again of the scale that we're operating at. I don't think it ever drops below 1,000 deployments to production in any given month, and in pre-production environments, it's generally well over 4,000. That's a lot of changes being made across the platform. A lot of these changes will be being proactively scanned with tooling we make available, such as ZAP, as I mentioned. But that in itself is not going to be effective in preventing vulnerabilities being introduced. I think I just want to be really clear here. The number of changes is not in itself a security problem. Indeed, I view it as very much the opposite. If we implemented a change freeze and set the whole platform in ASPIC for the next year, we would become far more vulnerable to security incidents, not less. A portion of these deployments will be to upgrade code to remove older versions with known security risks. Some of them will be bug fixes. All of these changes will be improvements to the services that we host that HMRC make available to customers, and the higher numbers, the better. So this is the catalog that I've briefly alluded to. It's an internal tool that we've developed in-house, but it's certainly possible now to buy generic alternatives. As a tool for us, it's something of a Swiss Army knife. It holds a vast trove of information about the applications. Nearly all of it is automatically generated, so there are no manual updates to any of the data. Everything is automated where we can. What's shown on this slide is what's running where, which is a really simple thing. You can see for any given microservice which version is running in which environment. But it's hugely useful when you're operating at this sort of scale to just be able to find that information in a really quick and easy way. There's also information on each repository, every deployment, and under the various other tabs that we have at the top there, lots of other features for viewing the microservices in different ways. This is one of the newest features of the catalog. It's the deployment timeline. In this case, we're showing how different versions of the same microservice have been deployed into different environments over the last 4 months or so. And as you can see, the general pattern here is deploy to pre-production environments, wait a few days, possibly to see if any problems arise, then deploy to external test and production. External test, that's what it says on the tin, really. It's an environment for testing with external people. And we consider it to be production-like. So if you deploy there, it's likely to be the same version as you have in production. There are obviously occasions where it might be sensible to deploy to all environments more quickly than that, such if you have a bug fix that you've seen a problem in production, you need to get a fix out as fast as possible. The microservice that this is looking at, one called Auth, is actually a mature service, and it's used by nearly every other microservice on the platform. So it's not undergoing the rapid development that you might see on some of the newer services, where you'll see new versions that might be deployed multiple times a day. I think that's quite enough context, and I hope I've not bored you too much. As I mentioned, HMRC is a target for all sorts of people. The motivation of such people might be disruption. We're a department of the UK government. Not everyone around the world loves us and what we do. Not everyone in this country loves the tax department and what we do. Some of them might be motivated to attempt a denial of service attack. There are 60,000 or so civil servants at HMRC. All of them have been security cleared to varying degrees, but generally not very high. There are also thousands of people working at HMRC as contractors, and ensuring that things work on the levers process is a huge challenge in itself. We're huge supporters of coding in the open, but it has to be accepted that that does come with a risk that sensitive information will leak into, in our case, GitHub repositories. We also have a lot of personal, if not sensitive information, running through the pipeline all the time, and some of it will be logged. We try to ensure that we don't log anything which is PII, personal identifiable information. But it does happen from time to time, and then we have to react and clear it up. There are some people who are always portrayed as hoodie wearing types. I've got a hoodie just here, actually, I could put it on, with a fear of direct sunlight. Some of those will be looking to gain access to the platform and the services hosted on it, whether they're motivated by a dislike of the new plastic packaging tax or for financial gain, or perhaps because they're being paid by a foreign state. And the last one there, vulnerable dependencies. Vulnerabilities and dependencies are something that have been of growing concern for a while now, just because of the number of high-profile instances of where it's been used as an attack vector. It is important to scan those dependencies, which is something that Gerald will go into more detail about. It's also really important that we actually know what dependencies each service has. And that's another hugely valuable feature that we have in the catalog. So I realize I'm laboring this point. Mitigating threats on a single service can be a full-time job. Think about doing it for 1,000 microservices. I mean, the scale presents its own challenges. And that's a problem that we've created for ourselves. We're victims of our own success in that way. Trying to keep a single service secure is a lot of work. Trying to do it for thousands, you can't, well, you need to find new ways of scaling to cope with that. It's going to require new tools and new ways of analyzing it, but it's a really, really useful opportunity because you can be far more efficient about this. So I guess we've recognized for some time that we have a problem. Our platform security team was really our first attempt to make security a first-class citizen of MDTP. We wanted to start looking at the security of those things that we had direct ownership of. And in a way, that was the easy part. Although I think, we can agree that, like love, security is a journey, not a destination. And with application security, there are other challenges. Previously, the HMRC model was that each service would have a regular pen test, and changes to that would be reviewed by HMRC security and then added to a security risk assessment that each service must have. And that's been stretched towards breaking point for quite a while now, for reasons that would come from both columns on this slide. And I think we basically decided that we could do better and that we could do more. And this is where the idea of a platform-based application security team came from. The first remit is really to go and lift some rocks, pull on some threads, see what the problems are. And then secondly, investigating what we can do to fix problems, and preferably to make that fix at a platform level so that we can protect all of the services running on MDTP and not require individual changes across thousands of repositories. At which point I'm going to hand over to Gerald. He's going to delve into the details of how AppSec is operating and what they've found.
Thanks, Ben. Let's dive into application security at HMRC Digital. But to start with, I'd like to talk a little bit about the relationship between those service teams and the application security team. Now, for this slide, I sort of tried to borrow from team topologies, looking at sort of service teams as stream-aligned teams that deliver value, but that's, the actual services, and the application security team as an enabling team. For my first stab at this slide, I tried to visualize the duality of centralization and decentralization of security as a hub and spoke, but it just didn't feel right to put AppSec at the center and have the service teams on the outside. I felt it sent the wrong message too. An AppSec team at the center shouldn't mean that the service teams are marginalized about security considerations. On the contrary, an active participation of the teams is essential, as it's them that understand the context, and it's them that can quickly determine whether a theoretical issue can be practically exploited. So I've ended up with this double Ouroboros. I've put AppSec Snooper as my job title, as I spend a lot of my time looking through key analogs, checking whether there's any interesting leaks, analyzing source code, trying to break services, and generally just find problems. And Ben's mentioned this quite a few times already, but I'm going to labor the point as well. This has been made possible by the fact that our platform has opinions. Without that fairly homogeneous set of services, it wouldn't be possible for the AppSec team to be centralized. We wouldn't be able to review code for 1,000 services if they were written in 15 languages. And when we find something, we go and get in touch with the owning service team and talk to them. It's not about sort of assigning blame, but it's collaborating on making it better. Services, of course, should feed back to AppSec. They should ask questions, they ask about best practices and report issues that they find themselves. But how can this be done at the scale? There's only a few AppSec engineers. We can't look at every CV, can we? Or really, but more of that in a minute. First, I'd like to look at what happens when we do find an issue. In MDTP, we use Slack a lot. Every team has a team channel, and we get in touch with them as shown on that slide. The importance of our tooling can't be overstated. Our catalog allows us to look up a service by name, quickly find a Slack channel of the owning team, and get in touch with the people. Especially at this scale, that's really important. I couldn't imagine doing this by email or making lots of phone calls to corral the right people onto a video conference at short notice. An ad hoc Slack channel is really useful because it also allows us to bring in additional people at a later time, and we can just point them to the top of the channel for them to get context. So once we've contacted a team, we would look through the findings together and sort of prioritize a fix. AppSec will put some recommendations there, but it's not up to AppSec to make the fix. After all, we don't understand the context of the service. It's also important to establish that this is a risk-based approach and that not all the issues can or should be fixed there and then. We have to be realistic. if AppSec insists that everything is fixed always at once, we would just generate a load of work, and what would probably happen is that the service teams would just avoid us, and we don't want that. Just sort of to finish off the slide here, AppSec usually brings in friends to the channels, to sort of the telemetry team to clean up logs, or the PlatSec team if there are wider impacts, as it could affect the security of the platform. Right, now that we know how to raise issues, let's talk about how to find them. Let's start with the perennial issue of the supply chain. Each of our services is made up of dependencies. These dependencies are libraries that typically open source libraries that have been built by somebody else. Sometimes they're supported by large companies, but more often than we'd like, they're maintained by Jeff from Nebraska as a hobby. Now, in MDTP, our services are built by the build server, the build pipeline, and the artifacts are stored in Artifactory. Now, Artifactory also happens to host all the dependencies that are needed to build the service. And as part of Artifactory, we've got a tool called X-Ray, which peeks into each of the built artifacts and all the libraries that are bundled up with it and lets us know whether there are any dependencies with known vulnerabilities. And when I first looked at it, it generated a report of over 800,000 rows. And what's worse, when I tried looking at it, this is what I got. That wasn't a great start. Now, it may well be that some of this is my fault because I didn't have a bank of 42-inch monitors, but most of these columns are abbreviated to the point of not being able to distinguish anything. And if I wanted to read the full value of a column, I'd have to hover over it. And then I looked at the fact that there were nearly 140,000 rows of data to trawl through. That's impossible. Thankfully, X-Ray is really very good at being interrogated by an API. So instead of the UI, we were able to write a sort of simple data pipeline, which pulled the data out of X-Ray, combined it with some scripts, and put them into spreadsheets. Yes, spreadsheets, my favorite tool. Instead of looking at 100,000 pages of reports, I let the scripts to do the hard work to aggregate the information. And I could then find out how many different vulnerabilities were in each service, how many different types of vulnerabilities we did have. I crunched the numbers, and broadly speaking, we arrived at some interesting observations. About 100,000 reports were coming from 180 different libraries, encompassing 500 different CVEs. Incidentally, CVE, or common vulnerability exposure, is what's used in security to refer to an issue that was uncovered. There's a wide range of CVEs that get uncovered daily, and there's lots. So keeping an eye on them is quite a task. The problem with CVEs is that a lot of the time it depends on the context as to whether something is exploitable or not. There are plenty of CVEs that are only a problem when a dependency is used in a certain way. Again, this is where having the paved road is really, really useful, because we know that the majority of our services are written in a certain way, using certain patterns. As an AppSec team, we can analyze whether something is an issue or not. Remember how I talked before about using spreadsheets? They really are one of the most useful tools in AppSec for me, the spreadsheets and the pivot tables. I do love them. It allows me to take some raw data, convert it into CSVs, import it into Google Sheets, other spreadsheets are available, and draw pretty pictures. The first interesting point came along when looking at the distribution of which dependencies were causing the most vulnerability reports. If you look at this slide, you'll see that there's one library that causes lots of reports. Why? Well, this library is quite popular. It's used in all of our services, and plenty of CVEs have been found. Maybe because so many vulnerabilities have been found already, more people spend more time researching in this and find more problems. I think there's a mathematical phenomenon called the ZIP mystery that might apply here. This library that causes so much grief is the Jackson library, and most of those CVEs are related to something called polymorphic deserialization. Briefly, this means it's only vulnerable when your service accepts a payload and tries to create objects based on that payload. Now, we don't do that. I've actually gone and checked all of our services to see whether there's any evidence to see whether we use it or not. So we're not vulnerable to this class of attack. The paved road is in our favor again. This means I can now confidently say that we don't need to look at those particular reports. So I can move on to the next library. This way, instead of having to manually trawl through thousands and thousands of reports, I focus on the ones that I can't exclude. And we did that. When we started to look at each and every one of those CVEs, one thing to note about CVEs is that they get assigned a score, the Common Vulnerability Scoring System score. And this score is between 0 and 10 and calculated based on a number of factors, such as whether something is remotely executable or not, whether it requires user interaction, etc. A lot of tooling, X-ray included, can provide policies to block those dependencies that have a vulnerability score higher than X. And the CVS score is actually one of my biggest bugbears. Looking at the data that we've got, in our case, we would have actually got a large number of false positives or false negative if we'd have just said, we'll pick a score and say anything above that we're interested in, anything below that we're not. In this graph, I've blotted out all the CVEs that we've encountered and classified them as to whether they require further attention or not, whether they can be safely ignored. So if it's red, then they can be safely ignored. If it's blue, we're going to require some action. And along the x-axis, we've got the score. The interesting outcome of looking at that data is that a lot of the really scary looking CVEs, the score of 9.8 out of 10, were actually not applicable in our context. Most of those were related to that pesky polymorphic deserialization problem. But also some of the very harmless sounding ones, for example, a score of 5.5, actually warranted further investigation. One example would be like a denial of service attack on a Spring library. Because of this, I find it's imperative not to use the score as some kind of filter. As an example, I'd like to put forward a vulnerability that the AppSec team has actually found for ourselves. That then got turned into a CV and classified as a score of 7.5. Now, with that vulnerability, it would be possible to send a single request to a service without requiring authentication and make the service exit. Typically on the platform, you'd have 2 or 3 or 5 or maybe 16 instances running, depending on the type of processing required. If you can kill all these instances with 16 requests, then you have quite an impact on those users. Admittedly, at MDTP, the services are self-healing, so those 16 instances would be back up within a couple of minutes. But if I'm an attacker, I could just send another 16 requests. And if I keep doing that, then the whole system would grind to a halt. And I tend to think of that as the sort of cruise missile precision strike rather than the carpet bombing of a distributed denial of service attack. Yet this type of vulnerability that we found is only a score of 7.5. And yet I could essentially use it to bring some parts of MDTP to a halt. I have to sort of add that we do have other mitigations in place that mean it's not as simple as that. Now, you might ask, why don't we just update all of the dependencies? And again, that's a question of scale. You know, that's fine if you've got 10 microservices, but it's not feasible when you've got 1,000. We'd just be spending all day, every day, updating dependencies, and then just like painting the fourth bridge, once we go through all the 1,000, we'd start again at the beginning. Although I've got a feeling I might be showing my age because I think they finished painting the fourth bridge. Sometimes it's also not possible to update easily. I've had situation where a problem was in a dependency that was brought in by another dependency, and the solution was to upgrade to the next major version, which wasn't backward compatible. Do I really want to rewrite the whole code for a security issue that might not even affect me? Also, some of our code is legacy code, which would take a huge amount of testing to upgrade the libraries. No, scores aren't the answer, and neither is updating everything. So what we ended up doing is to have this idea of curating the vulnerabilities. It means more spreadsheets. As an AppSec team, we would look at each and every vulnerability, read the description and decide whether there might be something else that needs doing for it. If our preliminary investigation would find it's exploitable, we'd raise a ticket and we'd look at it. If the preliminary investigation shows that this could be exploited really badly, we'd do something about it straight away. And this sort of curation, where we can look at issues, is that paved road again. It wouldn't be possible if you had lots of different patterns. Enough about CVEs and vulnerable libraries. Before I move on, I would just like to introduce some more of the tooling that MDTP provides and is used by both the service teams and by the AppSec team. One of my favorites is the Dependency Explorer. You can put in a dependency, as in a library, and search for every service that might be using it. You can check for the versions, and you can find all those versions that use a particular version. The above screen is the reason why the Log4Shell vulnerability at Christmas 2021 was scary for only about 10 minutes. I heard a lot of stories of security engineers spending sleepless nights trying to find out whether anything uses Log4j. We just typed in the right Log4j version into the Dependency Explorer and found that none of the services were using it. I can tell you that was a big sigh of relief. For anyone not aware, just briefly, the Log4Shell problem was a vulnerability in a very popular logging library, Log4j, that would trigger remote code execution just by printing a particular string to the logs. I would like to note here that this wasn't the only thing that helped us. The Log4Shell vulnerability would have required calling out to a random server on the internet, and we've got egress protection, which means that arbitrary calls to the wild, wild web are prevented. We also had another layer, a web application firewall, and this is sort of all part of an integrated and combined strategy of defense in depth. With regard to the Dependency Explorer, it's also important to state that this is really useful for service teams. I used to work on service teams, and the number of times as I went, or just need to find out whether something is being used or not. It's really important. Next, we've got a system called Bobby that allows us to put certain dependencies on a deny list. Pardon me. Now, you might scratch your head a bit there, because only a few slides ago I said that policies based on blocking and X-ray aren't a great idea. And then we turn around and say Bobby does exactly the same thing, but it's actually slightly different. We can fine-tune the dependencies. We can deprecate, and we can set dates at which the dependencies will be blocked to allow a smoother path to upgrading. This is great for enforcing platform library upgrades. We also make it possible to get through a build in an emergency, even though it violates a Bobby rule, that we make it as painful as possible. Bobby is also interesting because we have got control over the tooling, and we're able to build useful graphs. In this case, we can check whether the use of a library that has been deprecated is actually decreasing over time. Again, a problem of scale. With so many microservices, it's not easy to track who is upgrading and who is not. And these trends allow us to spot problems at a higher level. Another really useful tool is a leak detection service. This scans the source code at anytime when somebody makes changes and warns them if they've committed something that looks like something secret or something sensitive. This tool somewhat predates some of the services that are now available in GitHub, but even though the GitHub secret detection is there now, the customization that we've got in the leak detection service makes some really nice features. If someone commits a secret, platform security gets warned and the team gets a Slack message. Pardon me. The last tool that I'd like to mention is actually currently in development. Based on our work with the spreadsheet, we found that while Google Sheets was a great tool for ad hoc interrogation, it wasn't the easiest to pinpoint problems and show the curation status of a CV for teams. So one of the apprentices that is part of the team building the catalog took a look at it, and we're currently building a minimally viable product that will surface all those vulnerabilities for the teams. And they can just go to the catalog and look at what kind of problems are associated with their service. And because these will contain the information that the AppSec team will have added as part of the curation process, it will make it easier for the teams to sort of see what kind of issues are there, whether they need to take action or not. Now, after all these tools, I'd just like to talk about the fact that AppSec is hard. It's easy to leak something sensitive into the logs. It's easy to miss something while coding that can have a serious security impact. To illustrate this, I sort of thought I'll paint a picture of an own goal that we've had. We were working on the catalog and we wanted to improve observability. So we included some mandatory logins for everyone, and we also storing the requests that people made, and whoops, we've now stored people's passwords. Now it was only the platform operations team that would have had access to those passwords, but it's still a serious enough incident to say, well, you know, we don't want anybody getting access to anybody else's password. The important thing was not that something bad happened, but how we react. We calmly fixed it, identified the users that could have been affected, and got their passwords rotated. So if security specialists can make those kinds of mistakes, what else can we do to help service teams that are building this large bulk of services that we've got? And what we do is we need to stay proactive. Scanning vulnerabilities is all well and good, but it's reactive and it's in other people's libraries. In order to spot where problems occur in our own code, rather than waiting for the problem to surface on its own, we created something called the risk ledger. Actually, it's just spreadsheets again. Basically, we tried to identify areas where risky code could live. So as an example, based on experience, we know that parsing XML can lead to problems. So we've attempted to find every bit of code across all those thousands of microservices that parses XML. Same with what stores data or parses files. All of these can be thought as sort of threat intelligence. So, for example, when a new XML vulnerability gets discovered, it's really handy to have a list of everything that processes XML already. Like I mentioned before, and I'm probably going to do again, the problem is the scale. If we had a system of 20 microservices, it's probably possible to remember every place that passes XML, and, you know, remember it off by heart. For 1,000 services, that's just not feasible. Yes, I think we've made that point enough. To close, I'd just like to mention a couple of things about the future of AppSec and where we see ourselves going. So one of the things that happened not long after Ben and I first thought about this talk, we were on the MDTP virtual tour, which was like an internal conference. And one of our speakers was Terence Eden, who told us everything about coding in the open and how the NHS COVID contact tracing app was created by being open and transparent. Now, it wasn't a surprise to us about coding in the open, because HMRC have been practicing coding in the open for a long time. And a lot of the repositories that make up the services are visible to the public. Reasoning is simple. If the taxpayer pays for it, why shouldn't they be able to see it? For example, the code for the catalog that we've been showing, all those lovely tools, is public. Now, during that, it struck me that security and transparency are not incompatible. Now, it doesn't mean that I would advocate that we broadcast all the vulnerabilities on social media to say, oh, look, we've just found something and we haven't fixed it yet. That doesn't make sense. But internally, once somebody fixes a vulnerability, it's a really good learning opportunity. And from personal experience, writing about finding and fixing stuff is actually good fun and is a really good way of sharing with other teams. And one of the things that I like to say is security is very much about information, not raw data. For example, the data provided by X-ray is great, but without the aggregation and analysis, it's useless. And by being open and sharing sort of security information across the organization, it can be more effective. Along similar lines to sort of security in the open, we created an initiative called AppSec Amnesty. The idea here, again, is just to drive home the point that sharing information is good and that people can always share the bugs or the issues that might have impacted security with us. And that's a great opportunity to learn from each other. And it means that AppSec can go away and say, oh, well, could maybe look at whether this has happened elsewhere. Now, I know I've said in closing once before, but right at the end, I'd just like to summarize and maybe give you a few tips if you would be interested in standing up an AppSec team. First of all, the prerequisites. Do you have a paved road? I think a centralized AppSec team would never be very effective if there's a very broad technology stack. And you'd also have to know what services are running where and who runs them. A centralized AppSec team will not work if they have to spend a lot of time chasing down service owners. As we've seen, MDTP uses a catalog for that. Once you've got all that, I recommend starting by collecting threat intelligence. Find out which service writes files or talks to a particular sensitive backend system. Make a list, use a spreadsheet. And once you've got that manual process of aggregating the data, then you can write a script. Can that be done repeatedly? Can you run could be just a shell script on a laptop. But it's important that the data is collected regularly and analyzed, and then you automate it. And once the automation works, you can scale it out. Thank you very much to listening to my ramble, which has taken a little bit longer than I thought.
Yeah, thank you both. That was eye-opening, actually. I totally believe you that AppSec is hard. And your slide, Ben, about risk to services gave me the shivers. So it was really encouraging to hear about your proactive approach. So I won't ramble on for too long because we've only got about 5 minutes for questions. And hey, look, we've got 5 questions. Here's a bit of a challenge. Can we get through a question a minute? I'm going to start with one about developer experience from Lena Munaram, who says, it sounds like part of the process you've described is developer experience, defining the golden path, fast feedback, service catalog, etc. How much does DevX play into how you implement application security tools?
It's essentially, it's vital. Our catalog can be as shiny as we like. If nobody uses it, it's useless. So again, it's all about collaboration and it's all about understanding the needs of the service teams. AppSec team who sort of goes out on its own and writes lots of policies and says, you have to do this because we think it's a great idea, is going to meet a lot of resistance. So it is all about working together with the service teams. And I mean, from our point, I think it helped that before I started AppSec, I was a service developer for 4 years at MDTP. So I kind of understand exactly the kinds of things that people run into. And I think if it is a really crucial point that the people who are doing security have a good understanding of how things are being built.
That's another thing that came across, actually. I loved your focus on collaboration, transparency, and surfacing stuff without fear of blame, which is easy to say, but hard to do. Here's another question from Martin Gladish. Do you think these tools are ready or suitable for use in teams outside HMRC?
I take this. I don't think a lot of the tooling that we're using is bespoke, and I'm not sure how readily you could take what we're doing and, you know, immediately, you know, download the source code for the catalog and spin it. You know, that wouldn't work. What I think is ready is the approach that we're taking. I know there's another question on the particular tools that we're using. Because the platform is mature, because we started this 8 or 9 years ago, there wasn't the range of off-the-shelf tooling available that there is now, I think. So we have actually written a lot of this stuff ourselves, and, you know, we benefit from it, and we probably don't see a huge advantage in migrating away from it yet, but it's the approach that we're trying to publicize more than the specific tooling that we've got, I think. Thank you.
I think we've got time for one more question, and this one's from Robert Limbray. What are your dependencies on the network team, platform team, and do they impact developer velocity?
I think I can answer that. I mean, essentially, again, because we use this idea of the paved road, we don't actually get many requests, or we don't actually allow many requests where people go, oh, can you just spin us up a pub/sub queue, and we need a Kafka cluster, and we need this database. The opinionated nature of MDTP is something that we defend. You know, this is a hill we die on because it has so many benefits. We really try to promote a certain way that things should be done, which has the nice benefit that you don't actually need to go to the network team to go and say, oh, we need to open this and we need to do that and we need to do the next thing every time somebody comes along and thinks, oh, we've thought of a new way of building something. Now, at the same time, we're pragmatic. It means that if it isn't possible any other way, then, you know, the infrastructure team will go away and build something to suit a particular need. But it's only something that we would consider in sort of very extreme exceptions, I would say. Don't know, Ben.
Well, if I just pop in and say, I agree, we do try and be pragmatic, but any new feature that a developer on MDTP wanted, we would try and make sure that it would be useful for far more than one person or one team. If it's going to be used by, you know, 100 different developers, then we're far more likely to invest the time in making it available. And if we do make it available, we would want to ensure that it's self-service. And so it's not a case of, you know, if you want this, you have to contact Gerald and he'll do something manual to create it for you. We would make it so that, you know, it's something that you can achieve with a Jenkins job or a GitHub PR or whatever. In terms of just going back to Robert's question, I think it does have an impact on developer velocity. I think they can go faster. I think that's the reason that we have the platform. It's to allow you to solve problems and write your code faster. It's not like, you know, without a downside. And I think one of the downsides is that because we are limiting the technology choices, you're not going to be doing much that hasn't already been done. And I think that, you know, you need to want to be interested in building a service for tax users and not just for using the latest shiny technology.
But thank you all for attending. Somebody's asked about whether they can get hold of the slides, and a recording of this talk will be available shortly, but not immediately after the session. I'm going to end just by saying thanks again to Ben and Jerry for a fascinating talk. And thanks to everybody who's attended. Please join us for the next EE Expert Talk.